He is the Senior Program Manager for the California Solar Initiative Thermal Program at PG&E, which is based in San Francisco. His primary focus is on increasing the adoption of solar thermal throughout PG&E's service area. He is a renewable energy enthusiast and previously managed the team for the Bay Area solar company, Sungevity, expanding PM project management operations there and successfully growing their reach from coast to coast. Steve recently joined PG&E in 2015. And our second panelist, who also contributes to the California Solar Initiative Solar Thermal Program, is Devan Johnson. He is a licensed professional engineer and principal at KW Engineering, which is based in Oakland, California. He specializes in renewable energy consulting and has been providing technical support to PG&E in their administration of the CSI-THERMAL program since its inception in 2010. So without further ado, I will hand it over to Steve, who will take us through the next few slides of this presentation.
Great, thank you very much. I appreciate it. And hello to everybody out there. Today, our agenda, we're going to go through some basics of the CSI-THERMAL program. We're going to talk about some of the technologies involved, some of the sizing requirements involved. We're going to talk about calculating the actual incentives for utilizing the program and the application process. Welcome to everybody. I hope you enjoy this, and please fire off questions whenever you have them. You can find details about the California Solar Initiative Thermal Program on any of the participating utilities websites or at CSI-THERMAL.com. And what is thermal? Well, unlike PV, which takes the sun's energy and turns that into electricity, in this case, you're taking the sun's energy and turning it into thermal energy, directly heating water, air, or heat exchanging fluid for various end uses. There's an example, one example of how it works. On the bottom right of this corner, you'll see the tank there. The cold water from the municipality goes into that tank. Inside that tank, there are copper coiled wires that are filled with glycol, and that glycol gets pumped up to the roof, to the rooftop collectors, and it gets superheated up there, goes back into the tank through those copper coils and exchanges its heat into that water. That water is then held and intended as basically a boosted temperatured water that will then serve the house's main water heater, basically allowing it, the main water heater, to work less, to use less gas, and ultimately save the homeowner money. The program itself provides incentives for customers that install solar thermal technology in their homes or businesses to offset gas consumption specifically, as I said, for certain types of water and air heating end uses. Goals include increasing the market size of the solar thermal program in the industry in California, reduce barriers to adoption of thermal, including permitting costs, confidence in technology, etc. We also have a program where we are working with installers throughout the state to get them trained up and familiar with the program so that they can utilize it for their customers. And also to drive reductions in the cost of solar thermal, so it's a more affordable technology. It's a well-funded program. There is a $305 million program that's been legislated by California. It's administered by the utilities that are listed here and overseen by the PUC. Currently, the budget is allocated to natural gas. There was a propane and electric component, and those funds have been exhausted. So currently, we're offsetting natural gas. And it's broken up. The budget is in this format: 60% multifamily commercial end uses, 30% non-residential pools, single-family residential pools, and 10% single-family residential end uses. And that basically reflects roughly the projects that we've seen come through the program since its inception. There's also a very important low-income component with a dedicated $25 million budget that allows us to work with our low-income customers in order to allow them to enjoy the benefits of solar thermal. We work with some state partners on that, and they're able to utilize both our incentives and federal funds to provide low-cost or no-cost solar thermal for those customers. This is a breakdown of where we are currently with the incentive rates for the program. We're well within step one. Earlier this year, we raised the incentive rates. As you know, this is a gas offsetting program, so we're in a position where we're combating the low price of natural gas. So we've increased the incentive rates per therm. As you can see here, the old rates are crossed out, the new rates are there, been increased anywhere from 30 to 60% depending upon the customer, as have the caps that are associated with each project. The eligibility for single-family and multifamily residential, basically in PG&E's territory anyway, you have to be a PG&E natural gas customer. This applies for the other participating utilities throughout the state as well. Applicable end uses include domestic hot water. Basically, this is hygiene, cooking, anything that goes down the drain in a domestic setting. Process heat where you are space heating or space cooling, and non-single-family residential pools. This is a little bit of a confusing slide in that I just want to be specific that the only end use that's applicable for single-family residential is the domestic hot water. That's the only possible end use. No heating, cooling, or pools is allowed there. So I think we have a poll question at this point.
Yes. Let me get ready to launch it. So I'm going to launch the poll. I'm going to read it to you guys, and I think it'll just give Steve and Devan a little more feedback on what kinds of systems you're interested in for your projects. So let me launch it. So the question is, for which of the following building systems would you consider incorporating a solar thermal system? So you can choose any that apply. So your options are single-family domestic hot water, multifamily domestic hot water, commercial and or multifamily process, and then commercial and or multifamily process specific to pools. So I'm just going to give everyone a few more seconds to complete the voting part of this poll, and then I will reveal the outcomes. We're still seeing some activity. Okay, I'm going to close it. So Steve, would you like to guess what, I did not really brief you on who was signed up for this webinar, but do you want to guess based on what you've seen in the program so far, what people would have responded?
I'm going to guess it's going to be multifamily end uses that don't have to do with pools.
Okay. I'm going to share, I'm not sure if you can see the answers, but I'll respond them.
I can't.
So you can see them? Oh, you can't.
No, I can't, no.
So a lot, actually, so the winner here was single-family domestic hot water. And I guess I'm not really sure what, how many CAHP participants are also participating in CSI. So it would be good to know. And then the second pick was multifamily domestic hot water.
Yeah. Well, that's great. I mean, I guess this audience, that makes sense. It is kind of contrary to how we've seen the projects come in for the program already, but with this audience, I guess that completely makes sense.
Yep.
So should we turn it over to Devan here to talk about some technologies?
Great.
Sounds good. Steve, why don't you go ahead and I'm going to talk a little bit about some of the technical requirements and technologies involved, as well as some of the sizing guidelines in the program. Next slide, please. So there are certifications provided by the Solar Rating Certification Corporation, SRCC, as well as International Association of Plumbing and Mechanical Officials, IAPMO, for both packaged solar thermal systems as well as just the collectors themselves. For single-family residential projects in the CSI-THERMAL program, the system must be certified with the package certification, which is referred to as OG300. And it's important that the system that's installed matches that OG300 configuration exactly, with a couple of exceptions. There is an allowance if the certification applied to a tank water heater, that it can be also it can be applied to a tankless water heater, and there's also an allowance for substitution of a different make and model of solar storage tank, as long as the volume and the input value is equal to or greater than that in the certified tank. That's to allow a little bit of flexibility without sacrificing any of the performance. Now, those OG300 package systems include collectors, and the collectors themselves receive a certification called OG100. So it kind of makes sense that the smaller subcomponent is a lower number, and the package system is the OG300. So for multifamily residential, the systems are built up. The entire package and system isn't necessarily certified, but the collector itself must have the SRCC certification. And these organizations, both SRCC and IAPMO, have online databases for looking up what systems and collectors are certified. But that information is also available in the program calculator, which I'll demonstrate in a few minutes here. Next slide, please. So basic components really that make up the overall solar thermal system are those solar collectors, which, as I just noted, have a certification of the OG100, as well as sensors and controllers. There are both active and passive systems. Active systems have pumps. Passive systems are typically relying on either municipal water temperature or thermosiphoning effect to circulate. And then there's a solar storage tank for holding that solar heated water until it's needed for use. Next slide, please. So of OG300 certified collectors, there are a number of different technologies of collectors out there. Most commonly seen in California, I think, is the solar pool heating market, which has continued to be fairly active for the last 30 years or so. And these are typically these plastic or polymer type collectors. They're fairly low cost, and they're fairly efficient at heating water to low temperatures, but not the most efficient at heating water to higher temperatures. Next slide. What we see quite a bit of for domestic hot water heating are glazed flat plate collectors. So these have copper absorbers inside of an insulated package with a glazing that maintains some heat inside and reduces some of the thermal losses that those previous polymer collectors can see. And so these are capable of generating higher temperatures, and I think is what we've seen most commonly in the program so far. Next slide. And then evacuated tube collectors, we also see quite often. These are vacuum tubes, so they're providing insulation. They're also oriented in such a way so that they're collecting as the sun moves throughout the sky on these kind of cylindrical absorbers, and heat is transferred up to a header pipe, which is where the heat transfer fluid, which supplies the heat to the solar storage tank travels. These are able to generate even higher temperature than glazed flat plate collectors, and certainly than unglazed. They're often used in very cold climates, both because of their insulative capacity and because, as you can see in the picture, they allow for snowfall in particular to pass through. So in climates where there's snow, these can be a good solution. Next slide. These are likely not best suited for residential, but this is another type of collector that has received OG100 certification. It's concentrating collectors. And in this slide, we can see there are hybrid PV and thermal collectors, which the collector on the left is an example of, where it's generating electricity through the PV modules and capturing the heat through absorbers behind those modules, as well as thermal-only collectors like the one on the right. It uses a Fresnel-style lens to concentrate the sunlight onto an absorber and generate even higher temperatures. These are the types of collectors that would likely be used for high-temperature applications like solar thermal cooling with absorption chillers, or very high-temperature process heat applications. So again, probably not very suitable for residential. Air heating systems are also certified under the OG100. Transpired collectors are often used for direct air space heating. These certainly could be applied in multifamily, single-family residential. They're not very commonly seen in the U.S., although they have been used quite a bit in more northern climates in Canada. And essentially, they're drawing air through a lattice, which heats that air directly and can then be forced into a space for conditioning. Next slide. So there are some sizing guidelines that we provide. They're kind of based on some general solar thermal rules of thumb. Some of them are kind of there to prevent things like oversizing of systems unnecessarily. One thing to keep in mind with solar thermal is, unlike PV, which can be interconnected to the grid, the solar thermal is standalone and is really dependent on having that solar storage tank being sufficiently sized to store all of the hot water that will be generated by the system in a day, and also not to have excessive amount of collector area based on the amount of hot water that the facility uses in a day. So next slide. So where we start is by providing some guidelines for estimating the hot water load in gallons per day of hot water consumption. And this is the method we've come up with for single family. It's based on the number of occupants in the building. If it's new construction, it could certainly be based on the number of bedrooms with a presumed occupancy. So we assume 20 gallons per day for the first person, 15 gallons per day for the second, and 10 gallons per day for every person thereafter to arrive at our estimate of total gallons per day of hot water usage. And then we provide kind of a limit on collector area that cannot exceed more than 1.25 square feet of collector area for every gallons per day of consumption. The general rule of thumb is to have a square foot of collector area for every gallon of hot water used per day. And we've allowed a little tolerance on that because collectors only come in discrete sizes, and it allows a little more flexibility for collector selection. Next slide, please. So an example here using that methodology, if we had a 3-occupant single-family residence, we would take 20 for the first, 15 for the second, 10 for the third, and come up with a 45 gallon per day hot water usage estimate, which would result in this 56.25 CAHP of collector area. And this could be achieved through a single collector. A collector's very typical collector size is 4 by 10 feet or 40 square feet, or it could be achieved with 2 smaller collectors to really max out that amount of area. Next slide. For multifamily, we have referenced ASHRAE, American Society for Heating, Refrigeration, Air Conditioning Engineers, their service hot water sizing guidelines. And for multifamily, they provide maximum daily usage numbers per unit, apartment or condo unit in the building, and the number per unit varies depending on the total size of the building. So for an apartment building with 20 or less units, we would assume a 42 gallons per day per unit, whereas, you know, somewhere between 20 and 150, we would assume less, with a 40 gallons per day per unit number. So these are, again, the guidelines from ASHRAE that we're using to establish our maximums. ASHRAE notes in the handbook, footnote related to this table, that these are likely high numbers. They come from studies that predate low flow fixtures, and so these should definitely be treated as a maximum. Next slide. So we have a couple incentive calculators. We actually have 3, one for single family, one for multifamily, and one for pools. Single family, again, is for OG300 systems, and this is what the calculator inputs look like. For single family OG300 systems, part of that certification from SRCC or IAPMO includes an estimate of savings for each climate zone. So SRCC has done computer simulations of all of the OG300 systems in all of the California climate zones and climate zones throughout the rest of the country, and come up with annual therm savings numbers, which we use in our calculation. What you need to do to determine the potential incentive for a system is to enter in the system identification number, and that is something that a distributor, someone providing solar thermal systems, should be able to indicate for a particular system. It's also something you can look up in the databases provided by both SRCC and IAPMO that I mentioned earlier. A manufacturer and system type. There are a handful of different system types. And then simply identifying whether you're a single family or multifamily commercial customer. Zip code is used to look up the climate zone. We are, as Steve noted earlier, exhausted the electric incentives, so currently only incenting gas displacing systems. So you would always select gas here. And then azimuth, it's important that the azimuth be entered as a true azimuth, which requires that any magnetic azimuth has the magnetic declination added to it. We do all of our calculations based on true. The tilt of the collectors, which would be the pitch of the roof if mounted and parallel to the roof. And then the annual average access. This is the impact of shading on the site. So the shading can be calculated using a shading analysis tool such as a solar pathfinder or the Sometric Sun Eye. These tools take a fisheye image of the sky with knowledge of the where the sun paths travel to the sky. They can determine how many hours of the year obstructions are going to cause shade on a particular spot. For solar thermal, we are looking for access to sun between the hours of 10 a.m. and 3 p.m. If you have participated in some of the solar programs, it's worth noting that solar PV usually looks at full annual access, whereas solar thermal, because we're counting on really both the sunshine and a little bit of ambient temperature to create heat in those collectors, we're looking really at the solar availability between the hours of 10 and 3. And then the last input here is selecting the utility that the customer is in. So this is a very simple calculation. It will provide results immediately, and it will simply estimate the incentive, indicate which incentive step that's at. Those incentives decline as more participation is received in the program. You showed the table of incentives with the 4 steps illustrated in the previous slide. The surface orientation factor is really a D rate that's related to the tilt and the azimuth that was entered. This system example here has an ideal azimuth of 180 degrees true south and a tilt fairly close to latitude here, and so has no D rate due to its orientation. And then the annual average access, which again is that shading access between the hours of 10 and 3 annually, is 98%, results in this incentive of about $2,000 for this system that's saving 111 therms per year in the Bay Area Climate Zone 3. So again, fairly simplified calculator for single family.
And actually, question one slide
sure.
back when you have a chance. It was just on the backup water heaters. Wondering, I think it's more of a building design question. Do you need a separate water heater if you're installing solar thermal? I think.
Well, you do need the auxiliary heater if you're installing solar thermal. Solar thermal is not really suitable for supplying 100% of water heating. It's typically going to provide between 60 and 80% of water heating for a home in California. And you know, part of that is because we don't have a thermal grid to interoperate with, and we're relying on generating this heat for a solar storage tank to stand and wait until the heat is called for. So it's always coupled with an auxiliary heater. Now that auxiliary heater ideally will not be operating very often at all. But of course, if we have multiple days of rain, thick cloud cover, cold temperatures, then very little solar thermal heat will be generated. So it's typical that with a solar thermal system that all of the domestic hot water will be provided from solar during the summer months, but during the fall, spring, and winter months, less than 100% of the heat will be provided. That's really why we need that auxiliary heater, is to supplement during the parts of the year where the system is not providing enough heat.
Thanks, Devan. That was a really nice explanation. And I just want to point out, it sounds like some folks might be not hearing the audio super clearly, so we can just make sure our mics are close to our mouths.
Sure. Yeah, sorry, I moved it a little bit farther away. Hopefully that's a little bit better.
I think it might be, yeah. Thank you.
Okay, great. Apologize for that. Okay, so for the multifamily calculator, this is a bit more involved. Why don't you take it to the next slide, please? So this is a tool that we've developed as part of this program. It's not intended to be a design tool. It's really intended to estimate gas savings in a consistent way so that we can pay an upfront incentive based on that savings estimate. There are, quite a number of assumptions that are made within this tool that may not be consistent with every system installed out there. So, I caution using it as a design tool, but it is an excellent tool for coming up with consistent estimates for the incentive program. We're using the same simulation engine, which is Trensis, which SRCC and IATMO use to come up with the savings for the packaged OG300 units. but we're doing this on the fly. So this simulation is doing actually a 1 minute time step annual simulation. So it's stepping through a year in 1 minute increments, and it's fairly processor intensive. So the entire simulation can take about 15 minutes to run. And the way that the server is set up, if there are a lot of users performing simulations at the same time, they get queued up in a first in, first out kind of fashion. So it can actually take more than 15 minutes depending on the usage of the calculator at that time. So be aware of that. You're not going to get results immediately as with the single family calculator. Next slide, please. So this is a view, and I'll break away to give a demo in just a moment. And in fact, I will step through each of the inputs and describe what they are in that demo. So I think the next slide will launch us to the demo. Is that right? If you want to hand presenter to me. Okay.
Take.
So hopefully you can see my web browser.
Yeah.
Okay. So this is the CSI-THERMAL.com website. You can see at the top in the navigation menu here, we have a calculators item and the 3 calculators that I mentioned. The single family calculator, which I just discussed, which has this limited number of inputs and generates results immediately. And then the multifamily calculator, which I'll describe. So there's a user's guide linked at the top here, which provides a lot of information about some of those assumptions that we make under the hood. So if you're producing estimates from the calculator and have any questions, it might differ from something that you've got from another simulation tool or heard elsewhere, it would be good to kind of look at that user's guide and determine whether any of the assumptions we're making are inconsistent with some of the design of the system in question. So these are built-up systems, and there's quite a number of variables here to input, and I'll try to describe them relatively quickly here. But please feel free to ask questions about these inputs as I'm going through. So we can have heat exchangers on either side. We have a collector loop that is supplying heat to a solar storage tank, which then is delivering that heat to a load. And there can be heat exchangers on the supply side, which would be the collector loop, or on the load side, or on both. And those heat exchangers can be external to a tank, or they can be immersed in a tank, like in the diagram that Steve showed on how solar thermal works, that had an immersed coil within a tank. So we really need to specify whether the heat exchanger is on the supply side, the load side, both, and is it an external heat exchanger or an immersed heat exchanger. So if we follow the example in that earlier slide with the coil in the tank, that would be an immersed supply side heat exchanger where that collector heat exchange fluid is coming directly through the coil on the bottom of the tank. So I'll go ahead and select that option for now. The freeze protection is typically achieved either through what we refer to as an automatic drain back, where the pump shuts off, the collector loop pump shuts off, and all of the piping from the roof is sloped back to a drain back tank, which is placed within the building envelope, either in an attic or a garage. Doesn't necessarily have to be conditioned space, but within the building envelope. And that essentially removes all of that fluid from the exposed piping and collectors on the roof to prevent draining. And then when the temperature sensors sense that there's a temperature rise across those collectors, the pump will reactivate and circulate collector fluid and generating heat again from solar. And so that effectively prevents freezing. The other freeze protection method is to use a glycol solution, of glycol and water in the collector loop, essentially an antifreeze solution, so that they don't have to be drained but won't freeze. We will select glycol freeze protection for now. And one of the should say downsides of using glycol is glycol is susceptible to damage from overheat. So this is one of the reasons why we have sizing guidelines. If the glycol is allowed to stagnate, and that means sit in the collector without the pump active for long periods of time in the collector, it will come to a boil. And if it's boiled repeatedly, it will break down and lose its anti-freeze capabilities, and in fact get acidic and potentially cause damage to the system. So we require that there's some sort of overheat protection method that's employed to prevent that from happening. And there are a number of methods out there. It's possible to dump excess heat to a pool or a spa, use some sort of a heat dump radiator, or there are various control strategies that can achieve that, like controllers that will run the thermal cycling at night in order to generate load so that the system doesn't get into a stagnation mode in the subsequent day. Tank configuration, and I should note that all of these inputs are actually described a little bit further in the user's guide as well. Tank configuration really specifies whether there are separate solar storage and auxiliary storage tanks. They can also be one and the same. There are water heaters out there that have heat exchangers in them as well, and for gas tanks, to achieve that, typically it's a specialized gas tank where the burner is introducing heat in the upper portion of the tank, so a heat exchanger can be placed in the bottom and allow solar heat to enter the tank through that heat exchanger. So we really need to identify here whether we have separate tanks for solar storage and auxiliary, whether they're the same tank, or whether we have a tankless water heater or boiler. For this, I'll go ahead and select separate tanks. Now the collector, this is a list of all OG100 collectors, and you'll note that this is manufacturer model or certification number here. We can enter anything and it will start to match the specific collectors that have either a name, a model number, manufacturer, or a certification number that match what you've typed. And this limits this pull down to less than the multiple thousands of collectors that are certified, so that we can actually select something easily. Once we've selected something, it populates the area of that collector, which will serve as some guidance for some of those sizing guidelines that I mentioned earlier. And then we need to input whether the collectors are plumbed in parallel or series. These types of collectors we typically see plumbed in parallel. Total amount of solar storage volume, how many tanks that consists of, total amount of auxiliary volume, how many tanks that consists of, the backup fuel source, the nameplate heating capacity on the auxiliary water heater, the climate zone, which is selected here from the list of the 16 California climate zones. I'll go ahead, as with the previous example, and select 3, since I'm in the Bay Area, and that represents the Bay Area. A list of building types, which for multifamily would be apartments, condos, the hot water demand, and if we remember back to my multifamily table of hot water usage, we have 42 gallons per day per unit for up to 20 units. So if we assume a 10-unit apartment building, we would assume 420 gallons per day of usage. Identify whether there's a recirculation loop on the distribution system, set point temperature of the auxiliary water heater, and then there's typically a anti-scald mixing valve that mixes down that water temperature to something a little lower than the water heater. The array tilt, azimuth and true azimuth, and let's use the same 98 we saw in the single family example for shading. And then, as I noted, this will take anywhere from 15 minutes plus to return results. So you need to supply your email address, and it's also helpful to give it a name. In case you're running multiple simulations and you want to differentiate them. So that's the multifamily calculator, and assuming all the inputs are valid, you will be returned to this page that lets you know that the results might take a while. They typically don't take 24 hours, but we have had a couple points in time where there was a lot of usage on the server and it did take some time. And you will receive an email with the results once they're completed. And if they're very similar to the single-family results, where it will list the total firm savings estimated, the resulting incentive, and what incentive step that is based on. So let me pass it back to you, Steve, and I think that kind of wraps up my technical portion, and you can proceed with some of the application process.
Great. Can you see the screen again?
I can, yeah.
Yep.
Okay.
And
right.
actually, I think, well, we can save this. I've got a few questions, and we've got maybe 5 more minutes left of the presentation, so we'll just save the rest of the questions for the end.
Okay. Well, that's great. I'll just scoot through the application process and go toward the end of the webinar so that we can get to those questions. Basically, just want to go through this so you're familiar with the process. Won't get too deep into it. The application itself has to be completed through the CSI-THERMAL.com portal. It's done by a trained contractor, an eligible contractor who's gone through some mandatory training with the program administrator. In this case, in PG&E territory, it's Devan and I. The application process for single family is a one-step process. Once the project has been built and signed off by the inspector, by the AHJ, the incentive claim form and the building permit are then submitted to the program for payment. For multifamily, it's a 2-step process. Prior to the installation, the reservation is reserved. The incentives are reserved through the reservation request form. The incentive rate is locked in. You have 18 months to act upon that after the project's been built, just like a single family. With the supporting documentation, the incentive is then claimed. Payments are made on a one-time basis. Generally, for all of these projects, it's going to be on a one-time basis, lump sum, based upon the estimated therm savings provided by the calculations that Devan just went through. There are performance-based incentives as well, where if the project is large enough, we would require that the project is monitored over the course of 2 years, and the payments would be made based upon that monitoring. But in this case, that's really not applicable. It's more for larger commercial systems. Just to give you some perspective, this is a case study on a housing nonprofit here in San Francisco that had basically they had an energy efficiency initiative where they wanted to not only reduce their greenhouse gases but offset awfully high energy bills that they were experiencing as a result of heating up lots and lots of water using gas. They implemented a design and followed through with a project that included 64 collectors over 2 properties. They saved about 7,000 therms a year, and the project cost minus the incentives, the project cost was about $260,000. The incentive at the time was $86,000, and that note that that's the old incentive rate. It would have been about 30% higher than that if it was done currently, because of that rate increase, resulting in a much more affordable net cost. And in this case, there was no 30% investment tax credit applied because it was a nonprofit. But just wanted to illustrate the potential savings for this program in a multifamily setting. For a single-family setting, we're talking probably you're going to be covering with incentives anywhere between 40 and 60% of the total installation cost. And actually for new homes, it actually could be more than that because you don't have to do a lot of the workarounds for installation on a renovation type situation that you do. You wouldn't have to be doing that in your situation. So why does this matter to you? Well, because the incentives have been raised, it's the best time to apply to the program for multifamily up to $800,000. Maximum incentive for a single family, maximum about $4,400. It's a growing program, as I mentioned earlier. It's a well-funded program, plenty of incentive funds. There's non-residential pool incentives for multifamily housing and community pools. Standards are extremely high within the program. Folks like Devan and his counterparts make sure that the engineering requirements for these installations are very, very high. Returns and paybacks for projects going through the program are extremely good, the best they've ever been for the program. You can offset anywhere between 40 and 70% of multifamily installation costs. Payback, just rule of thumb, assume something between 5 and 8 years. So just some points of note here. The thermal program runs through the end of 2017 as it's currently planned. Then at that point, it will sunset. The 30% federal investment tax credit runs through the end of 2016. So if you want to pair those together, now is the time to act. As I mentioned, the incentives are the highest in the history of the program, and it's a great time to be leveraging them. So that's the end of this webinar as far as we're concerned here, and we can switch over to questions if you like.
Yes, let's do that. So I have a question about coordination between this program and PG&E's residential new construction program. So I can take that, or if you guys want to.
Please.
Yeah. Okay. So projects that come in through California Multifamily New Homes or California Advanced Homes can take credit for their solar thermal systems through those programs. They could alternately participate in the CSI-THERMAL program, in which case you would not be able to claim the energy savings that come from the solar thermal in the CAHP or CMFNH programs. So it's like kind of, you can only claim solar thermal in one or the other. So if you, in certain climate zones, you might be penalized if you're if you're compared to like a code standard building that includes solar thermal of a certain solar fraction. So we'll work with you on a case-by-case basis. If you're participating in CSI, but you do have solar thermal system, CAHP and CMFNH will, just make it really clear what our expectations are for not including the solar thermal in your model. Or modeling it to like a code standard would probably be the route that we would go. Do you guys want to add anything to that?
No, that was great. I don't. Devan?
No.
And we can share, I don't think we have a formal arrangement of sharing like plan review efforts. Part of the new construction program's application package is to take in a Title 24 set. So we're happy to share whatever results we get to reduce the cost of admin. Let's see. Okay, well, I'll move on to the next question. This is a question about code. Is solar thermal required by 2013 code? And then the second part of that is actually it's sort of a three-part question. Will it be required in 2016 code? And then the third part is, can I still get incentives if code requires that I install solar thermal?
Steve, I can tackle part of that.
Sure, go ahead.
I'm not sure if it will be required in code. I can't say that, but I haven't seen anything in the program language that would prohibit receiving incentives if it was required by code within the life of the program, which, as Steve mentioned, sunsets at the end of 2017. Of course, that probably won't come up until we discover if it is suddenly required absolutely by code during the life of the program. But so I don't know if it's going to be in code, but I don't think it would prohibit incentives during this program.
Great, and if you come up with anything, we'll send out a follow-up email to this webinar, so we can include more details on some of these questions in that email.
Okay.
So here's another question. If you have a 100% electric project that's pursuing zero net energy, can you still take part in the CSI-THERMAL program? Yeah, so that's the question.
Well, the site has to be served. This is Steve at PG&E. The site has to be served by gas, and there would have to be that existing in order for you to be offsetting natural gas. So if it's a completely electric situation, Devan, you can check me on this, but I believe that would not then qualify for.
That is correct. Yeah, we will be expecting that there is a gas auxiliary water heater in place that the solar thermal system is displacing. It would have been incented under the electric budget that was already exhausted.
And as far as I know, I don't think there's any barriers for CAHP or CMFNH to take an electric project that's using solar thermal. So if you are participating in one of those programs, just let your contacts know. Or if you're interested in participating, we'll have our contact information up right now. So you can follow up with us. So yes, I guess there is an alternate, which is nice. Okay, here's another question. I have a project currently in entitlements phase, which which I think he means expect to kind of be moving on in 2016. They haven't started design development drawings yet, but want to see what incentives would look like. At this point, what should I do with regards to the CSI program?
Well, if you're asking if the incentives are expected to change between now and then, as I illustrated in the chart earlier, there is a step down that if there's an allocated budget for each step, and if we do run through the budget for that step, then you will revert down to the next step. That said, we're well within the first step. I can't say that I expect that we'll jump down into the next incentive level, so I expect that to stay there. In terms of actually applying, if it's a multifamily scenario, once the design is done, there will be some requirements on what you can submit in order to lock in that incentive rate at the current level. And if it is a single family situation, then once the project is built and you have the final sign off from the HJ, that's the time when you'd be going in and doing the application. I hope that answers the question.
Yeah, so if this person now is just maybe contemplating what kind of system they want to install, should they get in touch with you now before they have the mechanical system set in place, or should they wait until they know what that'll be?
They can wait. In fact, one of the best ways of doing it, I'm not sure of how the partnership works between the person who's posing the question and who would be doing the contracting work, but the application itself will have to be done through, as I mentioned, an eligible contractor. So you'd have to actually reach out to one of those contractors. There's a contractor search tool on the CSI-THERMAL.com website, and through them, you'd be able to work out a plan about when is the most appropriate time to activate within the program. Hope that's helpful.
Yeah, I think that's really helpful. I think that's probably what he's getting at. Feel free to enter a clarifying question. We're also at 1 o'clock. So unless I see any questions coming in the next few seconds, I think we can start wrapping up. And we'll send out a follow-up email. And as soon as you guys close out of this webinar, you will be greeted by a survey, which we would really appreciate if you would fill out. It helps us make our presentations relevant for you and interesting for you, and also if you would like anyone to follow up with you about the residential new construction programs, you can indicate that. And I'll send out in my email, you'll get the slide deck and the recording, and also you'll get Devan and Steve's contact information so you can contact them with questions about the program. I think that does it. So thank you for taking an hour out of your day to join us, and thanks to Steve and Devan for presenting. I learned a lot about solar thermal, and we look forward to seeing you on future presentations. Have a great rest of your day.
Thank y'all.